Yes, we can hear you.
Okay, it's better. Okay, great. How was the homework?
It was good.
Oh yeah, I want to explain something. Okay, first of all, we have a midterm. So let me write about the midterm. So I will post it soon. But let me add it here. So our midterm is gonna be next week. Midterm is gonna be in June 13, next week. So make sure you are ready for midterm. So I will add all the materials that need to be get ready for the midterm. What I'm gonna do the previous day before midterm, which is gonna be 12, I'm gonna solve a few questions regarding the midterm and how you can solve them and some of the things. Does it make sense?
Yes.
Okay, so that's the midterm. I will post this one. Midterm is gonna be take home, but you need to write all the details. And one more thing, so because I'm gonna submit it through, it's gonna be submitted through Canvas. You cannot like use any materials, you know, so you can use internet, but if you use anything to just respond to your, so you write the solution, you need to cite them. Unfortunately, I'm really serious about this. I just explained the first day. I had the issue last quarter with the students that do cheating. So I was, at the end, I need to report them to university. And they lose a lot of points on the final too. So probably it's important, it's take home, but it doesn't mean that you can copy paste something from internet. Just want to make sure it's clear. Does it make sense?
Yeah, I got it.
Okay, great. So that's the midterm. So I just want to let you guys know about the midterm. So one of the things that's just really interesting for me, unfortunately, I got a few emails about that. Like when you try to do this limit, f of n, just want to clear this one. So this, let's consider this one L. L has some numbers. L can be, L can be infinity. L maybe not existed. If it's not existed, is not useful, because if it doesn't exist, you cannot use this algorithm for that. Or L can be 0, or L can be between 0 and infinity. So that's the thing. There are these options actually. So we can't talk about this option in the past. You remember? So, but I do see that you guys have some issues with that. So let me clarify again about this when you are trying to solve. First of all, you need to make sure L is existed. If L is not existed, it means that you cannot use this one. And then there are 4, like 1, 2, 3, 4. If it's not existed, you don't use this one actually. But there's 2 things that you can like use. Like L, as I explained earlier, if L is infinity, so what does that mean? Does anybody know this one? What does that mean when L is equal to infinity?
Does that mean that f of n is big O of g of n?
No, it's not big O. I'm not sure why you guys make a mistake. I saw email too. This is big omega. So big O is not, actually you cannot find big O with this. These numbers only give you big, a small omega, a small O, and theta. You cannot find big omega with this one, or big O, because the things that I should show that one. So like one of the things, if L is infinity, this is gonna be small omega of g of n. if L is equal to 0, it's a small O of G of N. And L
Professor,
is-
I don't want to
Mhm.
call you out, but my friend is in queue for Zoom. Can you just accept him in?
Okay, so
Thank you.
yeah, I didn't see it because I'm writing, so okay. And if L is between these two, it means that L is gonna be theta of G of N. So I got an email that you calculate L is equal to 1 and write that this is O, big O. Yeah, it's true. Big theta consider big O, because when you have theta, it means you have big O and big O and big omega. But it doesn't mean that when it's between these, it's theta. So that's one of the things I want to clarify. Does it make sense? I know these values have, because if you remember the graph that I drawn, so it means that this one have theta, but when you consider both of them, you need to write it as a theta, not big O or big omega. This theta means that it's big O and big omega, both of them exist at the same time. Does it make sense? This thing is like actually there is one part you can consider this one big omega 2 because they have overlap, but this means most of the time when you have this, it means that they are in a small omega, but that's going to be considerable too. I can do this plot again, or big O, because we have like this intersection, but when you have numbers in the middle between 0 and infinity, for sure is theta. Does it make sense? Okay, so that graph that I draw, I don't do it here, but there was one part, L doesn't exist. This one is when L existed. And then we have some part that they have overlap between big O and big omega. You remember this part that it was theta. Just check this one. We have it in lecture 5 actually. Is it clear now? I want to make sure that it's clear, because you need it for the final exam or for homework, for the midterm.
Is there any way you could post an answer key to the homework so that we can,
I
see
will
what?
put solution. I will put a solution.
Thank
Yeah,
you.
yeah, I will post a solution for all of these now. That's
Also,
not-
sorry. Also, do you know when we'll get it graded so that we can see what we got wrong and right?
I'm waiting for university. They didn't get back to me because I found a TA, you know. I'm waiting for them to get back to me to say, oh, okay, so that we can have a TA, but they didn't respond to me yet, so I don't know myself.
I got it. Thank you.
Yeah. So yeah, I just want to do some hints on this plot. So we say this one. Let me write it again. Just want to be clear. Just let me actually draw it again. So make sure you got it again. So that was one of the things I just got so many emails on. I can do better than this. Okay, let me do it in this configuration. Let me do a different color actually. So this one, this blue one, it's big O. This blue one is big O of G of N. Does it make sense? And when it's inside is a small, because a small O of N is like this one, and this part is when L is equal to 0. Then we do have this big one, which is big omega of G of N. And then I do have another part inside, which is a smaller. This is going to be a small omega G of N. Oh my gosh. This is gonna be a small omega of g of n. It's when L is equal to infinity. And then I do have another part. This is in the middle, which is gonna be this part. When L is between 0 and infinity. L is trying to do better. So this is when L is between 0 and infinity. Whole this part whole is like theta g of n. And then other part that is not inside the small part is when L doesn't exist. All of this part, you know, this part, and this part. Does it make sense? So that's the way you solve the question. If you do this L, you cannot find, if the L doesn't exist, you cannot find it. If there is a small, it's a small O. And if it's infinity, it's a small omega. And in the middle is gonna be like theta. Is it clear now? I don't know if it's clear or not. So, okay. Sounds good. Let me move my Zoom chat over here so I can see you guys. What are you writing? So, okay. So let's finish. Okay, that was like a note. Let me write this. That was a note from previous class. Let's start our session here. Lecture 8. Okay, so you remember last time I was talking about what we are talking about. We talk about finding. So let's go back and start writing about what we were talking about. So we're talking about the trees, the recursion. We talk about recursion, tree, and iteration method. Does anybody have any question on that? What does it do actually? What was the purpose of this one actually? Anybody know?
Does
Why?
it find a big O for the equation?
Actually, it's not finding a big O. It's finding a good guess. It's not mean that it's gonna be big O.
Yeah.
It's finding a good guess for an asymptotic bound. Probably maybe there is a possibility this one can be like big theta. You don't know. So that's gonna be possible. You can guess. That's the guess. If I want to be really clear, that's the way to guess it at. If you don't know anything about it. But one more thing that we need to know, if you move forward with this, we can push this computation that we do the other day. Computation a little further. To obtain an assumption, instead of just guessing, to obtain an asymptotic estimate. First of all, we say, okay, I want a good guess. You can use it for a good guess, but there is a way that you can directly use it to find the asymptotic estimate directly, not only guessing. So let's go back and see how can I solve this kind of problem. This is a really interesting one. So I want to start with that one. Okay, I do have an example. Let's go with this example. There is a T of n, as I explained earlier, this iteration method. So you say, okay, if n is it between 1, I'll consider this one really big. Let's consider T of n to be equal. C, it's a constant when n is between 1 and n naught, and it's if n greater than equal to n naught, it's gonna be t, like floor of n over 2 plus t. What does that mean? So probably if you remember, I told you guys about the like quiz today. These numbers, it means that doesn't matter that much for us. What are they? They're C and D. There's some numbers. They're constant for sure. We know this is constant, but we don't know what are they. So let's see. If I want to define something like this, this part is constant, but as you can see here, we can define something like that. So okay, I don't know what is this. This theta of n should look like d, which is here, d plus, because at the end of the day, from n1 to n0, this c is a constant. We care about this part. Let's consider this first, okay? It's t of like over 2. Because here you start with n, it doesn't matter. If you put n, this is n over 2. It means they are related to each other. So I just use this like happy face to show that they are related. So let's go back and use this one. So okay, I want to use this one. How it works? It's okay. Because at the end of the day, after n naught, everything is gonna be this equation. So it's okay. If I say t of n, it's equal to d t of n over 2, floor of 1 over 2. Let's do one more step. What is the one more step? Because d is here. You remember, I used this smiley face. It means t of a smiley face is equal to this one. So it means I can use this one. Instead of this smiley face, I can put it. So this part is equal to d plus t. I put the smiley face above, so it's become n over 2 over 2. So now we do have this one actually. So we move forward. So if you look at this one, so you see that. So it's gonna be like this part. It's gonna be n over 2 over 2, and we close this one. And this is the exact same thing. That's the reason I put a smiley face there. So let's move. Let's keep going. So this one is become 2d plus t n over 4 floor. I'm just doing this. Let's keep doing it. What do you mean? What does it mean if I keep doing it? So it means then next time I use the smiley face again. So n over 4 is going to be another smiley face. It's going to be n over 8. So if I keep doing this one, as you can see, in next step, when this is 4, this is 2. It means I can put this one kd plus t n over 2 over k. We can find a relationship because every time in every step, when in step 1, d is 1, this is going to be 2, like 2 power of 1. And when you are in step 2, 2d n 2 to the power of 2. So it's going to be the result. So we understand this is going to be the result based on keep pushing this relationship. Now we know the current terminate at the first. The smallest k for which I remember I started just saying, okay, I don't care about the first equation, but you know, after n naught, this is holding. If anything is smaller than n naught, it means it's not going to be this equation. So we need to find the smallest k that work for this equation. And so let's see. The smallest k that we can find. So, okay, what is that, the smallest k? So probably if I want to do this one, so I will say, okay, for the smallest case I want to find it, n to the power of 2k is less than n naught. It means that this part, if it's less than n naught, is the smallest one that is going to hold this equation. So because this equation not going to work, because this is the part that we are talking about. So, okay, if I consider this one or say, okay, what's going to happen? So do the floor. So it's going to be n2 to the k less than n, because this is the definition of like floor. So this is going to work. And say, okay, I'm going to change this one. I just put n over n naught, bring this one here. It's become 2 to the power of k. And then let's do something else. Let's do the log from both sides. So this is going to be log of n over n naught. This is going to be because of these two. If you do log of 2, so it's going to be k. And this one, what is going to be? We need to make sure this is not, because of this definition, it's going to be between k and k minus 1. So if that's going to hold, let's do something else. So, okay, this is going to hold. This is a definition that I have. So what is that shows? If I do have this equation, since we remember, like, the lower of x is between x minus 1 and x. That's a definition of flow. And that's what I use here too. Here when I use this one. If that's the case, what does that mean? It means that based on this definition, it means that log of n divided by n naught, it's a floor, is equal to k minus 1. And k is gonna be log of n over n naught plus 1. This is the k I found. So now I found the k. So what is that showed me? It says for this k, we have, what do we have? We say, okay, t of n is gonna be d of log n over n naught plus 1 and plus c. This is the exact solution that you can get for this, because you just use this one, you know? You say, okay, if I go here, so if I want to do this one, I put k, I put k here. This is the definition. Put k here. What is the k? K is this one, is log of n over n naught. And then what do? K, this is coming from here. Let me write it again. We use this one as the equation 1. If you use this one here, equation 1 is become this one, d log of plus 1 plus c. This is the exact number because we consider about another exact, because this is coming from here. If you put this t and then it's gonna be here. You know why? Because when I consider this one, I put k, which I find k. I put t n over 2 over k. I use k. If I put k over this one, and based on the definition, it's become n naught between these two, it means the result is gonna be c. So that's the reason we reach out to this one. This is gonna be the exact same solution. Exact solution. Does it make sense? Is it clear? So if it's the exact same solution, so what does that mean? I want to put it, I just want to find, I know I don't care about exact solution. That's the thing. Yeah, if they ask you find the exact solution, this is the way you do it. But we don't care about the exact solution. What do we care? We care about asymptotic notation. So if that's the case, let's open this definition. This is gonna be log of, like, for lower of log of n minus log of n naught, and then plus d plus c. I just open this one, just bring it up. So this one is gonna be what? So this is the definition. So because I have a floor, it means that it's lower bounded. So it's gonna be theta of d log n, because this is gonna be less than, if I consider this is gonna be less than, based on the definition of floor, this is gonna be less than of theta log n, and it's gonna be when it's met between these two, based on this definition, based on this, between this one and this one. So that's the reason it's become theta. So I consider this one, it's called theta and d minus d log n naught plus d plus c. So that's the thing. this all are number. So I don't care about numbers in asymptotic notation. As I explained before, numbers is nothing. We care about something that has n. So this is, D can be neglected too. So number is not important for us. So this is going to be big theta of so the solution of T of n is going to be theta of log n. So that's the thing with the asymptotic solution. Why these numbers is not important? These numbers, where are they coming from? These numbers are, for example, if you run it in your computers and another person computer, that's number, that's constant coming from configuration. But this n, it means that it doesn't matter which computer you use it based on your input, this is going to be the result. So we are comparing the algorithm based on the number of input instead of based on which configuration you use for your computer. Does it make sense? Is it clear? Anybody has any question?
No, that makes sense.
Okay, so let's see. There's another homework that you guys can solve, like the problem that I explained on like quiz. You can solve it as the exact same solution too. You can solve it for the exact same solution and find the result. So probably you can do that too. So that's not hard. And then like you guys can do it too. It's like applying iteration method to find the recursion there. So that's another thing. So you can solve this problem actually as an example. Applying the iteration method for this one. Please do this one at home. So, and then if you have any question, reach out to me. But don't neglect this thing. This is gonna be, you need to know how to solve this one. So this is a little different than what I wrote, but use this exact same solution, the way that I explained, and find. This is the way that we say is like iteration method. Does it make sense?
Yep.
Okay, let's go back to really, really important actual that we care a lot. Like the name of this way that we solve this one is master theorem. Master theorem or master method is the one of the important one, which we can use it a lot for solving a question. So let's go back to write about the master theorem. The master method, which we can call it master theorem. So how it works? First of all, when you hear about any theorem, you need to know what is the purpose? What is the purpose of this theorem? So if I want to talk about this, we say the master theorem determine what? It determines asymptotic solutions to occurrences of the form. First of all, this is the form. Let's T of n should be equal to A T of n over B plus F of n. This is the way. So it's going to be really important. So this is the form that you need to have. Some of the important things, A should be greater than 1, greater than equal, B should be greater than 1. And one more thing, F of n be asymptotically positive. That's some of the rule. If this is not whole, you cannot use this master theorem. Just be careful. So that's one of the things you need to know. So, but one of the things, I understand this is the definition, but what is this T over NB defined? So what's the point? Let me write that point here. So we say that T of N over B denotes either T of failure of N over B, failure of N over B, or ceiling of N over B. N over B. This is the way. And what we can say, so, or maybe that T of N is theta of 1. It means it's a constant for some finite set of initial term. It gives you ability to just, if you have the previous question, you can use it, you know. That's the part of the content of theorem that these details, while they may change the exact solution, do not change the asymptotic solution. What does that mean? It means, yeah, it means that these numbers or just being like, instead of ceiling having floor doesn't change the asymptotic notation, but it's going to change the exact solution that we use. So it means that if you have k equal to 2 or 3, everything gonna change. But here it doesn't, we don't care. We care about like asymptotic notation. So most of the time, such reoccurrence describe the runtime of the divide and conquer algorithm. So why we use it? Because we can say that such, you will see it in the course soon, that this relationship, such relations, describe the runtime of divide and conquer algorithms. Because in divide and conquer algorithm, your algorithm suppose divide a problem to different n subproblem into a subproblem, and each of them has a size of n over b. So why? So we say because, as I want to explain, because that in divide and conquer, algorithm, algorithms that divide a problem of size n into a subproblems each of size n over b. So that's the reason. Things that you want to solve your question, instead of solving a whole problem, you will solve it in a subproblem. Each subproblem is going to be size of n over b, and then you have a of them. So that's the reason we have the structure of this master theorem here. So it's like, okay, a, b, and then a whole structure. Okay, now I understand that this is the context that how this form of master theorem works. Okay, but how do you want to define this like algorithm works? So let's go to the next page. So let me write it here. Really important algorithms, actually theorems. So it's okay. So I want to write it here again. Master theorem. What is going to say to us? We say let, again, a greater than 1, b greater than A is greater than or equal to 1, b greater than 1, and f of n be asymptotically positive, and let t of n be defined by, say, t of n is equal to a, t of n over b plus f of n. If that's the case, then we have 4 different cases. We have three cases. Let's write the 3 cases here. First one, case 1, we say if f of n is big O of n log a b minus epsilon for some epsilon greater than 0, then we say t of n is big theta of n log a b. So that's the first one. So if this is the exam, if you can find this one, this is going to be the first one. What is the second one? So if f of n is big theta of O of, like, big theta of n log a to the power of b minus epsilon. No, it doesn't have epsilon, sorry. This one doesn't have epsilon. So then what do we have? We have Tn is gonna be big theta of n log a b and then log n. So this is the second one. And the third one, we write the third one. We say if f of n is big omega of n log ab plus epsilon for some epsilon greater than 0, and we have another important, and we say a f of n over b less than equal to c f of n for some c between 0 and 1, and for all sufficiently large n, then what's going to happen? Then theta n is gonna be t of n is gonna be theta of f of n. That's gonna be the solution. Does it make sense? So that's
Sorta.
the way to do. What?
I
Sort
just
of?
said sorta.
Yeah. So let's explain what does that mean. Just go move forward and see is there any how it's work, and then we will find out. So that's the way it's gonna work. In such cases, most of the time we compare f of n to the polynomial n log a b. So what is the approach that we are doing here actually? So if you wanna write it, we said that in these cases, in probably most of these cases. So if I want to write it here, we say in each case, because we consider based on the v, in case we compare what do we compare? We compare f of n to polynomial n log ab. Then based on then determine of these two functions is of a higher asymptotic order. Higher asymptotic order. So what does that mean? In case, for example, is 1 n log AB is higher than f of n, so then the solution is going to be class of the last one. So let's see. For example, 1. In case is 1 n log AB is of a higher order than f of n by a polynomial factor of n3 and the solution T of n is in the class of the second one. It's going to be in class of theta and log AB. So that's the first one. In case this is the case 1. I'm going to write it. So case 1, the first one. In case 1, what do? We check n log AB, and then we check it, is it higher order than f of n by a polynomial factor of n3, and then actually not n3, I'm so sorry, n epsilon. So I'm so sorry. So it's n epsilon. Because if I go back, let's check it here. The first one, what it does? The first one, check log AB and n epsilon. If this is higher, so it means that if f of n is higher by a polynomial factor of n power of epsilon, and then the solution is going to be in the class of this one. This is the solution. In case 3, like case 3, what's going to happen? We check again. We say, okay, f of n is higher order, again, by a polynomial factor of n to the power of epsilon, to the power of epsilon. And there is an additional regularity condition, because we can condition, there is another condition in the last one. Regularity condition is satisfied. If this is the case, and then master theorem what's that? It tells us, so it's going to be the master theorem, then tell us, in this case, T of n is going to be theta of f of n. And the last one, in case 2, two functions are asymptotically equivalent. You remember I talked about equivalent. It means that when we get the limit, the limit is going to be equal to 1. Then T of n is in the class of theta n log AB log n, which is going to be theta of f of n log n. This is the definition. Does it make sense? So that's the way that we solve the question based on the each cases. It means every time you just look at the f of n and just compare it with n log AB. If you check it out and then realize, oh, this is smaller, higher, or equal, so that's done. You don't need to just do this epsilon, find this epsilon, because the definition of like big theorem, just okay, if it if f of n is big omega, if f of n is big theta, if you know it, sure, go. You can go for it because you know that f of n is theta of this one. But if you don't know it, if you don't know what is f of n is big O of this part equation, it's hard to say, okay, big O of n log AB minus epsilon. That's hard. The way you approach it, you just compare f of n with n log AB. You just compare these together, which one to see if it's case 1, case 2, and case 3. Let's solve one question. But first of all, before I write it, I want to write it here and give you guys a few minutes to solve it yourself. And then based on that, we can discuss. This is the example. This is the example, which is going to be T of n, A T of n over 2 plus n3. So this is the definition. So maybe make it a smaller, leave it. That's the best we can do. So just, you know, which one is A, B, and then we define this one. A T of like n over B plus f of n. Just consider, find f of n is higher than n. We just say we compare it with n log AB. Compare it. If it's equal, it's going to be like case 2. If it's bigger or lower, so we can decide. Just solve this one and let me know how it works. Just 5 minutes, you guys figure it out how you solve this one. Does it make sense?
Sorry, can you clarify? Is it log A over B,
It's
or
not
is it
over, it's log. Log, it means this is the part, like
and
base.
sorry, base B?
Yeah, base
I
B,
see.
log, yeah, log A in base B. Okay, just give you guys a few minutes to figure it out. Let me solve this one first, and then you guys maybe can do the second one. Okay, so first of all, first step, find the number. I know A is 8. What is B? What is the number B?
2.
What is the B? What is f of n?
N cubed.
Okay, yeah. Okay, so what we need to find, I know f of n cubed. Let's figure out the relationship between n3 and n log AB. N is, so this is gonna be 8 to the 2. So, and if I write this one, it's gonna be based on the log. So it's gonna be n log 2 power of 3 to the power, oh, sorry. It's gonna be n log of 2 power of 3, 2. So this is gonna be equal to n power of 3, 2. If you calculate this one. They are in the same, you know, and this f of n, as I explained here, if in case two functions are asymptotically equivalent, because why? Because if things consider this one as like p, if I divide f of n with p and get the limits, it's gonna be 1. So, and then this is gonna be equivalent. They're equivalent. So if they are equivalent, what is it said? If they are, then theta n is class of n log AB log n. So what is gonna be that one? So if I calculate that one, theta is gonna be n to the power of what? Log AB, which is gonna be 3. I calculate that one. N3 and then log n. So this is the solution. I already found the asymptotic solution. This is gonna be T of n is gonna be big theta of n cube log n. Is it clear?
Yep.
Okay, so let's consider the next one. So now this time is your turn, you guys' turn. So it's easy. I want to see, as I explained earlier, so probably I know this all the students based on their like how they contribute in the class, if they respond to question and anything. So please solve this one and let me know, because I want to know your name. So, and then it's easier because I want to consider like attendees and then contribute in a class. So this is 5 T of n over 4 plus n. This solve this one. There are three options. If they are in the same order, it's going to be case 2. If it's f of n is higher, it's going to be case 3. And if f of n is less, it's going to be case 1. And then you can solve it. So just start it, and then based on, you can tell me, is it higher or is it the same or is it less? And then we can get back to how to solve it. Just now, I think you guys know how you're going to solve this. It's not the same. No.
Meow.
So what did you consider less? It means case 1. So less is gonna be case 1. Okay, one person respond case 1. How about other? This is the 3 cases. Let's solve this one more systematic other than just guessing. You need to see how do you approach this problem actually. So I think being more systematic makes it easier to just like using this one, because we need to show, is it which one gonna hold? So does anybody has any other idea before I'm starting to prove it? Why this is case 3? F of n is higher than log AB. I don't know if I pronounced your name correctly, Savannah. Hopefully I pronounced your name correctly. Why did you consider case 3? There is no right and wrong answer. It's okay. If you're just trying to see how. Okay. Okay. So let's solve it actually. Let's start. I will write, okay, this is gonna definition a t of n, f of n. Okay, a is equal to 5, b is equal to 4. First of all, I calculate this one, log of ab, which is gonna be log of 5 in base of 4. This number is 116. So it means if I consider f of n is n, this number is 1.6. It means this is gonna be n to the power because you consider this part. You're comparing two things together. F of n compare to n to the power of log AB. You consider this one. This is the n, this is n1 point, this one. It means this is higher. So if I want to consider this one, what I'm gonna say, I say, okay, there is an epsilon, which is I can consider log 5 minus 1, which is gonna be 0.16. So that's why we say that f of n, because f of n, the smaller number, is gonna be big O of what? It's gonna be n log 5 to the base of 4, 5 to the base of 4 minus epsilon. That's the first case I explained. So I say, okay, if it is big O, it means it's smaller. So it's gonna have smaller this one. So if that's the case, for some epsilon, we can consider epsilon, which is gonna be, it is 1.16. If I divide minus 1, it's gonna be 0.16. So that's the case. If that's the case, it means which case is gonna hold? It's gonna be case 1. And when I'm case 1, what is this case 1 apply? Case 1, what it says? Case 1 tell us it's gonna be theta of n log AB. So it's gonna be theta of n log 5, 4. Does it make sense? Is it clear? Okay, let's do something else. Let's do one more time. It's being clear. Let's consider this one this time. This time, go ahead and do this one. I just explained everything. Let's do this one. Tell me what is the difference. So they're quite similar. So find A, B, and f of n, and find this one and tell me. Yes, third case. Okay, so let's see how it works. So, one of you guys that explains the third case, can you help me to write it here? So just tell me, I will do the steps that you are telling me to write. One of you guys gonna start? Any of you? Yusuf, do you wanna go move ahead and tell me how did you solve it? I'm not sure. Is anybody in the class?
Yes.
So we're here.
Okay, so I don't know, 2% said. Okay, that's fine. Okay, let's just start it. Because they wrote that they say it's case 3, I don't want you guess it, so just solve it. I start with a equal to 2, b equal to 4, and then f of n is, sorry, f of n is ns. So, sorry. What we are proving, as I explained earlier, so probably we are lost in the middle. Just give me one more to figure it out, this color. Okay, so the issue need to ask, what we are doing, whole this process, whole this class, the purpose is that I want to write an algorithm to solve the issue for industry, for myself. As I explained, let's see, I want to write, as you're an owner, you're a business owner, you come to me and say, okay, write an application for me, write an app for me that can get the data from customer and suggest them what to buy. Like any customer service website, or just you want this one. It's like, okay, you say write an algorithm for me. It's okay, I will write an algorithm. So I will go and write an algorithm that I can use it in the app, and then anytime that there's one customer log in, I can suggest them what to buy or recommend them, like Netflix. I think like easier. Netflix, when you are logging based on your history, suggests you what to watch. So, but think, there is an algorithm behind that Netflix recommendation system. So ML engineer and AI or data scientist wrote that code to just give you a recommendation. But for writing that, you need to write an algorithm. So just writing and we'll move it in the middle, because I need to write an algorithm for recommendation system like Netflix. I need to write it. So if you ask me to write it, I can write like really complex code as, I don't know, 2,000 lines. It doesn't mean, this line doesn't mean anything. Nobody cares that you write 5,000 or the things about care, everybody cares right now that when they ask you to write a code, they ask you to write a code in a way. If new data coming based on the input, your solution is fast. Your solution is fast. What does that mean? So, okay, you log into your Netflix account. It takes 10 minutes, or I don't know, 1 hour to suggest you anything. So probably it's not gonna work. Or like, think that you do Google search something in Google. It takes about 10 minutes to show up what's going on. So that's the reason solution being fast become important. So, but yeah, I know solution become fast is important, but how do you define that your solution being fast? So probably you guys play game in your computer. So if you play a game, you know how like CPU, memory, and everything is really important. So probably if you use 2 different computers, the gaming is going to be different. So that's the way that they come in the like society, like a CS literature, that okay, I care about solution being fast, but I want to generate algorithm, systematic way that it doesn't depend on it doesn't depend any computers. It's going to be general. It just show me if the input increase, what's going to happen to that algorithm. So that's the thing that is coming from. So they consider relationship between n and like the time, runtime. So that's the reason it's coming important. It's like, okay, I'm trying to say runtime. I say, okay, if I have, for example, my algorithm, so like if I have 10, like probably you see the issue. Like ChatGPT, sometimes it says that if you use it, say, okay, the maximum number of the user is already filled, so you cannot search anything. Nowadays it's better because they use Azure as like, they just use Microsoft as the back, they help and support them. But in the beginning, as you remember, the number of users go high, they could not support. Why? Because there was a storage, and we can talking about the runtime, we can talk about like memory time, so we can talk about memory. So that's the other things, maybe there is no enough memory, or this is the runtime. So we care about the number of the user or the number of input with the runtime. So that's the reason they talk about big O notation, big omega, etc. So that is coming from here. So you want to make sure when your input grows in your algorithm, what is the solution gonna be? What is the runtime of your solution? What is is your algorithm is fast enough or no? So for example, that's when we see this plot, like runtime plot, so that they say, okay, if my input is here, so it means if I increase my input, my algorithm solution is going to be constant. It means if you have 1 million user, it takes 1 second. If you have 2 million user, my algorithm still takes 1 second. That's a perfect algorithm. That it doesn't matter how many user you have. But probably that's not the case for algorithm. We have another one, which is going to be n. It means if my user gets higher and higher, my algorithm is going to be slower and slower. It's going to be a relationship with n. We have something better, which is log of n. So it means if my user grows, the algorithm becomes slower with log n relationship. There is some algorithms which are worse. It means if I have an algorithm running that one, it becomes n squared. It means over the time, when the input grows, this algorithm is going to explode. Or worse, it's going to be n cube or something like that. And there is between n and n squared, we have another, which is n log n. This is better than n, it's worse than n, it's better than n squared. So all of these things that we write here, everybody try to find an algorithm with lower runtime. It means this runtime becomes smaller. But how do you find this runtime? This is the whole asymptotic notation I'm talking about. So why I care about these cases? Because I explained, first of all, when you write an algorithm, how do we write an algorithm for solving a problem? We can use divide and conquer. When we do divide and conquer, we realize this is the relationship and we want to find a asymptotic notation. And then if I come here, for example, for this example, let's see, this one. This is my algorithm. I wrote this algorithm and then the relationship is n cube log n. It's terrible. This is a really bad algorithm. Not only it can take n cube log n, it means it's worse than n cube 2. And then we have this algorithm. The second algorithm that I wrote, so it's in case 1, it's can n log 5 to 4. It means it's greater than n, but it's not that bad. This is a good algorithm. And if I go here, this third one, I think the third one is n log n. No, this is n. And the previous one, I think, was n log n. Which one was it? N log n. Oh, this is, yeah. I think this is n log n, n cube log n, and this is gonna be this one. So it means that this algorithm is better than the previous one. So I use this one, and the last one was this one, the runtime here. So probably we use this one. So we say, okay, I didn't write the last one actually. So we say which algorithm, based on this, we decide which algorithm is better. Is it clear now, Nick? We are proving to see, okay, if this is my algorithm is like this, it means that I divide my algorithm, my problem to 5 sub-problem. Each 5 sub-problem has n/4 inputs, and then I do have n to the square for some of the like for loop or the other. And then based on that, I want to find my asymptotic notation, and I will decide based on these 3 algorithms to go which one is better, which one is worse, which one I want to use, and which one I don't want to use. Does it make sense? Is this clear for everyone now? You guys understand what is the whole purpose of all these definition, and then why we are talking about runtime, why we put so much effort. So because at the end of the day, I show you guys in LeetCode. So when they trying to hire you as a software engineer or machine learning or a data scientist, they will what they do, they give you a problem, they give you a problem and ask you to write a code. And then they want to write the code in less big O or less big theta. So for example, if between these two, when you do have interviewer, if you write code and then there is one code is takes n squared, it means based on if the n grows, this is gonna grows with n squared. There is O of n, it is n log n. So the thing is that if you write this code, it's probably based on the code. This is not a good algorithm. They probably ask you, could you do better? And the better is going to be n log n. You can do n log n, which is better. And then if there is a way, maybe they ask you, okay, can you do better than this? Can you do better? Which is going to be O of n. All of these things, by how did you find this one for your algorithm? We use this theorem. So to figure it out how to solve it. That's the only purpose of all of this asymptotic notation that I teach these 2 weeks. Is this clear now?
Yep.
Okay, so probably that was the most important piece to know why we are teaching this. Okay, so now I know these things. Let's calculate everything. So I do have these, but what's going to happen? So I do have this one. Let's calculate log of AB, which is going to be log of 5 in the base of 4, which is going to be 116. So, and then this is n squared. So this is going to be bigger than this one for sure. So it means that there is epsilon. So if I write it, so okay. F of n. Oh. So which is writing f of n is going to be b n squared. F of n, which is going to be n squared, is big omega because it's bigger, is upper bound of n log 5 base 4 plus epsilon. Because it's this is bigger, it's 2 and this one is 1.16. So if that's the case, we have the case what? The case 3. But for case 3, there is something we need to check. You remember, when I talk about case 3, I say, okay, case 3, not only you need to have this one, which we do have, we should say A, F, N, B less than C, F, N for C between 0 and 1. So let's see if it's going to hold. What is going to be that one? So we say, okay, 5, which is going to be B of n over to the a, which is going to be 4, should be less than equal CF of n for some c between 0 and 1. Let's see if we can find out if it's going to work. For sufficiently for n large. For sufficiently n large. For large n. Let me write it here. Actually, for large n. So that's going to be the whole. So let's see. What is going to be? It's going to be 5 f n to the, okay, let's change this one. Let's say n to the 4 cube because this is cube, and then less than c n squared, and then we just move this one. It's going to be n 5 over 16 n squared less than equal to c n squared, which is true because if I consider c between 5 over 16 and less than 1, which is going to be something between 0 and 1, it's going to hold. So this is gonna hold. So by case 3, what do we have? We have T of n is big theta of n squared. So let's look at all this algorithm that we write. This is 1 theta n squared. This is case 1, which is gonna be n log n, which is gonna be theta of n 1.16. And then we have n cube log, the previous one is n cube log n. This is terrible, this is not good. This is not that bad because in a square, but this one is better, this algorithm, because it's n 1 point something is better than a square. So we can say, oh, this algorithm, the second algorithm is better than the others. Does it make sense? Anybody has any question?
Nope. I think it makes sense.
Okay, so we are finished by now. I will post the homework tomorrow for the next part. The next homework is gonna talk about like this asymptotic notation. Consider we just using this like recursion method, iteration methods, and just like the master term. So we will write these ones. So I will post it. So you need to submit it before the midterms. It's gonna be the week after that. So you have 1 week to solve that one. So I will probably figure it out by tomorrow if you have PA or not. Other than that, I will start write the solution, upload the solution. I will upload the, I will grade the quiz and homework too. And that's it. I think, yeah, that's it. And what we are gonna do, I want to have the quiz at the end of the class. So today, so you guys have, I will give, I know that it has a lot of layer of calculation. So for me, in my opinion, 20 minutes is enough to submit the quiz. But probably if it's hard for you, some of you guys, I will finish the class. Just you guys have 20 minutes. So I will stay in the Zoom if you want, but you guys have 20 minutes to solve the like the quiz, but I will give more than that. I'm gonna give 40 minutes if somebody has some issue to submit it. It doesn't mean you need to stay more than the class, but if you want to solve it, just go for it. I think 20 minutes is enough, but does it make sense?
Yes.
Sorry, can you repeat that? I got the last part, but you said there's the quiz in the last
Yeah,
20 minutes
there's
of
a
class?
quiz. Yes, I'm gonna post the quiz. You have 20 minutes because the class is finished at 6:40. You have 20 minutes to finish the quiz. So, and then you are done with the class, but probably if you're not done, I will give the quiz for 40 minutes. 20 minutes is enough. If you finish it, just done, it's good. You can move forward, but if you are not, you have 40 minutes. The reason I'm just telling you guys, because I don't want to go over the class for quiz.
Yeah, I
So
get it. Especially for
I'm
the
gonna-
uploading.
Yeah, in my opinion, 20 minutes is enough, but let me push the quiz actually. Let me post it. Okay, quiz for like edit everything. Let me give the time. So right now it's gonna be up to 7. You guys have time to 7. Available from 6:20. Oh, 6:20 and up to 7. Okay, so I think everything is ready. I pushed the quiz. So can you guys see it?
Yeah.
Okay.
You just need the access code.
Yeah, it's a start with quiz 4, but it a start with big 4, like with the Q, capital Q. I'm so sorry. So I'm not sure why one person joined for the quiz only. It doesn't make sense. Was it in a class? It's not gonna work like this, guys, because it's not gonna work that you just join for the quiz because it's part of like being in the class.
I think it's the same amount of people. I think someone just got kicked out.
Yeah, let me ask because